find some different values. First of all, what is that hypotenuse length going to be? Do y'all remember?
17?
It is 17. Very good. It's another triple. Yay for the triples, okay? If you ever have discussions with geometry students, brothers, sisters, or whatever, let them know those triples are really important. They save you so much time. Okay, so I want to fill that in because if you look at what they're asking us to do there, first of all, they ask us to find cosine of theta over 2. Okay, so let's go. There's a formula. These half-angle formulas are in here. They're on page 390. And cosine of u over 2 or theta over 2 has a formula, and the formula is plus or minus the square root of 1 plus cosine of the angle itself, just the regular angle. I'll go ahead and write theta, divided by 2. So I can see that I'm going to need to know the cosine here, right? What is the cosine of that angle? Adjacent over hypotenuse would be, what, 15 over 17, right? If you look at just the regular triangle. So that's what I'm going to be plugging in here. As a matter of fact, they're going to ask us to find the cosine of u over 2, sine of u over 2, tangent of u over 2. So I can tell while I'm at this, let's go ahead and get the sine value because we're going to need it in the formulas. All the formulas call for the sines and the cosines. Okay, so what would the sine be? Opposite over hypotenuse would be?
8 over 17.
Good, 8 over 17, right. Okay, so now I've got these. I'm going to use these in my formulas over here. So this is kind of what I need to get so I can breeze through my formulas a little easier. So that's going to be plus or minus 1 plus, and the cosine value was 15 over 17 over 2. A lot of simplification here, right, that's going to be required. If I want to deal with this, remember PEMDAS says we go under the radical. And let's simplify the numerator first. If I want to change, if I got to get a common denominator in the numerator, it would be 17 over 17. So this over here would become 17 over 17 plus 15 over 17 under the radical. Wouldn't that be 32 over 17, right? I'm going to change it like that, and then put it over 2. And for a minute, you're going to feel like you're back in 6th and 7th grade when you learned all this stuff because it's been a long time and you got to go back and now remember it. All right, and then if you've got a fraction on the top, we're going to write it down. We're going to change the division to multiplication under that radical, and instead of dividing by 2, we're going to multiply by the reciprocal, which would be a half, right? So that becomes plus or minus. Let's go ahead and reduce that fraction. That would be a good thing to do. 2 goes into 2 once, and 2 goes into 32, 16 times, right? So now what I have under the radical is 16 over 17. Okay, and I should simplify, right? Plus or minus. This, remember, when you have a fraction under radical, you could take the radical and put it with each number. So that becomes plus or minus 4 over the square root of 17, and that's considered not nice, right? So we have to rationalize it by multiplying by square root of 17 over square root of 17. And so that's plus or minus 4 square roots of 17 over 17. All right, so if we plug that value in, it's the same formula. It has a subtraction sign instead of a plus sign inside. That's the only difference. So I know that to simplify this, I'm going to have to do some of the same things. It's 17 over 17, but this time it's minus 15 over 17 instead of plus 15 over 17 over 2. And then we got to simplify another complex fraction. So in the numerator, I'll do that one in a different color this time. 17 minus 15 is 2 over the common denominator of 17. And then we have the denominator of 2. And so if you remember your complex fraction rules, you keep the numerator, you change the division to multiplication, and then you take the reciprocal of the denominator. So the reciprocal of 2 is a half. Well, this one's going to maybe be a little easier because look at the 2's, they're canceling out, right? So I'm getting plus or minus square root of 1 over 17. And so I remember that with radicals, you could split them up like this. So isn't that going to be plus or minus 1 over square root of 17? What do I need to do to that? Rationalize it with multiply by 1 in a funky form, square root of 17 over square root of 17. We'll get rid of that thing in the denominator that we got to get rid of, then radical, and I'd get what, square root of 17 over 17 plus or minus.
If we were to do the tangent.
Okay, so tangent has two formulas. You know what I'm going to choose here? Just put it on my computer desktop. There you go. Thanks. So I'm going to use this one, and the reason I'm going to choose this one is because I look over at the second one, and do you see how there's two terms in the denominator? Because there's two terms in the denominator, I figure that's going to be more work to clear it up. You know, I'd rather have one thing in the denominator. So that's what I'm going to do, is just choose the first one. And again, you could choose either one. It's just the algebra will look slightly different. Honestly, I don't know that it's going to be any more or less work in this case. Now, the cosine was what, 15 over 17, right? And the sine, I believe, hopefully y'all have that on your paper, is 8 over 17. Is that what we had?
Mm-hmm.
Okay. So I just got to clear this up. Okay, well, 1 is the same thing. I can rewrite it as 17 over 17 to get a common denominator. This is going to go faster because there's no square root. On the top, 17 over 17 minus 15 over 17 would be what, 2 over 17? And then you got your 8 over 17. And this is going to work out very nicely because you keep the numerator, change the division, the fraction bars division changes to multiplication, and multiply by the reciprocal of the denominator, and looky there. 17s cancel out, and we'd get 2 over 8, which reduces to a fourth. That one wasn't so bad. When you don't have the radicals, it makes life easier. So the tangent actually is not usually the easiest formula, but here it actually is, so it's nice. And we'll just stop with that. If you look at the remaining ones, they would be really quick to get because the secant of theta over 2 would just be flip the cosine of theta over 2. What did we get for cosine of theta over 2?
4 square root of 17.
Okay, so we might want to back up. Was it 4 over square root of 17?
Yeah.
Okay, so since the cosine was 4 over square root of 17, all I got to do is flip it, and I got the secant. So you see how the other ones would go pretty quickly. We'll go ahead. What did we get? The cosecant would be flipping the sine. What did we get for the sine?
1 over 17, all of that square rooted.
Okay.
Or I guess
All right, let's see. It was 1 over
one.
1 over square root of 17. So if we
Yes.
flip it, wouldn't it be the square root of 17? Right, I think. I think it was plus. Aren't all these plus or minus also?
Yeah.
Okay. Or some of them are. These two are, I think. And then for the tangent of theta over 2, the cotangent of theta over 2, which is part of what's left in here, you would flip just the tangent. So we got 1/4 for the tangent of theta over 2. Flip it, it would be 4 over 1, or 4. So once you do the work on the first three, the rest of those inverse functions end up being pretty equal. There is some more on here. This 2 sine theta over 2, cosine theta over 2, we'd have to go just plug in stuff there, so I'll just do G. I'll do the part G. 2 sine theta over 2, cosine theta over 2, we just plug the values in. If sine was, we get for sine of theta over 2, 4 over square root of 17, I think. No, square root of 17 over 1.
That was the cosecant. The sine is 1 over square root.
Okay, so 1 over square root of 17, and the cosine was 4 over square root of 17, right?
Yeah.
If I flip that other one up, there's what I'm thinking again. So then, actually, I could plug those in unrationalized, and it would be easier, right, if I kind of step back from when I had rationalized them. And I'd have on the top, 2 times 1 times 4 is 8, and square root of 17 times square root of 17 is 17. So on the G and the H part, that's all you're doing is you're plugging in stuff that you already have figured out.